Hello everybody, and welcome back to another geometry lesson. Today we're going to take a look at section 1.5. Today is the day we talk about angles. So what is an angle? An angle is just a set of points in a very specific way. It is a set of points consisting of two different rays, two different rays joined at their endpoints, which we are going to call the vertex. Joined at their endpoints. So as you see from the figure here, we have two different rays. We've got ray BA, starts at B and goes through A. We've got ray BC, that starts at B and goes through C. That makes an angle. The vertex of the angle is going to be that common endpoint. So point B is the vertex. As for the sides of the angle, they are made up of two rays. Like we said, one of them is BA, and one of them is ray BC. When we talk about angles, these angles can open up to a variety of different measurements. This angle down here is not open very wide. This one down here is. So to distinguish them, we talk about an angle's measure as a measure of their degrees. The degrees are the measure of an angle which is the difference between the real numbers from here to here. We would say measured with a protractor for this definition. Measured with a protractor. What do I mean when I say a protractor? Well, it's this sort of thing. This tool right here is a protractor. It's got a whole bunch of ways of measuring angles. Yours may have this little arm to help you out. I'm definitely going to be using that. But I also want to show you how to use a protractor without an arm, when it's just looking like this. We'll get to how to use this thing a little bit later, but just know you will need a protractor for this class. So let's talk a little bit about what we mean when we say the interior or exterior of an angle. The interior of an angle is, well, you might have guessed, the space in between the two rays. That is the interior, whereas the exterior is all the space outside of those angles. So all of this empty space outside of the angles is the exterior. When we talk about angle measurements, we don't care about how far the exterior is most of the time. Most of the time we're referring to the interior measurement. So let's take a look at how to name some angles. Down here it's asked to name the following angles in all ways possible. When we are given points like this along an angle, there are a couple of ways to name it. This symbol here is the symbol for angle. And it's always going to be that same sort of 60-degree angle looking piece. So we could call this angle DEF because it goes from D to E to F, just like how we named our polygons. We could also go backwards, FED. We could not go something like DFE because that's not in order. However, for shorthand, we could also call this one just angle E, because E is the name of the vertex. I'd like you to try and name these angles. This one here will have one name. This one here will have one name. This one here, this set of combined angles, will have a total of 7 different names you can call all the angles within it. So pause the video and try to see if you can name them all. Hopefully by now you've had a chance to pause the video and try it out. So let's go over what these are called. This is angle Q, because that's the name of the vertex. This is angle 2, because it's the name of the vertex. For this one here, we could call it angle S to refer to the big angle, but there are a lot of smaller angles within it as well. For instance, if we ignore point U, we can call this angle RST or TSR. RST or TSR. If we ignore the bottom or the top line, we could call this TSU or UST. So angle TSU or angle UST. Finally, if we ignore the middle line and just focus on the biggest angle possible, we can call it RSU or USR. So RSU or USR. Very nice. Angles can also be congruent to each other when they have the same measure. So if angle LMN has a measure of 50 degrees and angle XYZ has a measure of 50 degrees, we could say the two are congruent. Again, we could ask, what is point L congruent to? Well, it'd be congruent to point X because they match up in the congruency marks. So remember, we still have to go in order from letter to letter when we talk about congruency. An angle bisector is interesting. We've talked about bisectors for segments, things that can cut a line segment in half. But there are also things that can cut an angle in half. An angle bisector would divide an angle in two. And here's how it works. Let's say we've got, I'll make it an obtuse angle here. We'll talk about what that means in a second. So this is an angle that we might be able to cut in half. If we want to put in an angle bisector, we would want to make a ray that cuts this directly in two. I think that this would be the angle bisector. So if I gave it some points, like A, B, C, and D, we could say that, whoops, sorry, I mixed up my letters. This should be C and this should be B. In this figure, we could see that CD bisects angle ACB. It cuts it in half. So we have to give congruency marks to each of the angles. I'll give one tick to both angle ACD and angle DCB. So we know that those two angles are meant to be the same. Let's flip the page and take a look at classifying some angles. So we've got all different kinds of angles. We have small angles, we have large angles. There are 4 different types that we can discuss. If an angle's measure is greater than 0 degrees, but less than 90 degrees, then it's acute. An acute angle is a small angle that is in between 0 and 90. If an angle's measure is 90 degrees exactly, then it's a right angle. If an angle's measure is, I'll just write out the words this time, greater than 90 degrees, but less than 180 degrees, then it's obtuse. An obtuse angle is like that example that we drew down here for angle ACB. It's bigger than 90 degrees, but less than 180. And if your angle is just a straight line, we call that a straight angle. If it's 180 degrees exactly, it's a straight angle. So before we do the examples up here, to help us what we just learned, I do want to skip to example 6 to show you different types of angles. For part A, that angle is going to be bigger than 90 degrees, so it is an obtuse angle. It's also less than 180, so we're fine. 89 degrees is less than 90, so we will call that one an acute angle. C is 90 degrees exactly, so that is what we call a right angle. Right angles are always marked with a little square box in their corner. And a straight angle is usually marked by an arc, showing that we go all the way 180 degrees until we have a flat line. That is a straight angle. Let's take a look at some of these examples. I'm going to encourage you to pause the video and try these out on your own. However, I also want to go over them. So if you feel confident, go ahead and try these out all the way through example 6, which we've already done. If not, stick around and we'll do this together. So in this figure here, there are a ton of possible angles. Let's start off by getting rid of this ray here. If we did, there would be 3 ways we can name this angle. MNP, PNM, or just angle N. The problem is, angle N is very difficult to see. It would be this angle here. If we got rid of this ray, we could call that one angle N. I'm going to stick with calling it MNP. PNM, though, just because if this angle was N, it would have a marking on it. We could say that N is this angle, or both of them together. Since it's difficult to decide, I'm going to exclude marking that off as angle N. However, we also can imagine, what if this middle line was gone? If the middle line was gone, this would be the straight angle, MNO, or ONM. Finally, if this left line was gone, we would have the obtuse angles, PNO, or ONP. Those are all the angles in the figure. For example 2, we see that we have a word problem. The backyard of a house is illuminated by a light fixture that has 2 bulbs. Together, they illuminate an angle of 147 degrees. If the angle illuminated by only the right bulb is 35 degrees, what's the angle illuminated by the left bulb? I think for this type of problem, anytime there's like a word problem, I like to draw an image so we know what they're talking about. So let's say this is the roof of my backyard. This is like an awning or something that lights up the whole backyard. And I have 2 light bulbs. I have light bulb A right here, and light bulb B right here. Overall, they together illuminate an angle of 147 degrees. So together, they light up an area that's pretty big. In fact, I'm going to draw it as an angle. So there's my vertex. They light up this space between them. But the right bulb only illuminates an angle of 35 degrees. So light bulb B only lights up this area, where it's 35 degrees. Again, if the entire area is 147 degrees, degrees total, that looks like 1478. I apologize, everyone. 147 degrees. How much does this angle illuminate? This bulb illuminate? Well, we know that 147 minus 35 will give us this area. So we can do 147 minus 35 to equal 112 degrees. That's the area that light bulb A can illuminate, or the angle that it can illuminate, I should say. For example 4, we just have to name 2 angles. Now I'm going to choose to name it angle FDC, the angle that's encompassing everything, and the smaller angle EDE, or CDE. In this figure, CDE is 25 degrees, like so, and EDF is 18 degrees. So how much in total do we have? The measure of angle CDF can be found by adding the two together. If I decide to add together CDE and DEF, I would end up with 25 plus 18. The measure of angle CDF, which we mark as M angle CDF, is going to equal whatever those two add together to make. In this case, 43. The measure of angle CDF is 43 degrees. Finally, when it comes to measuring an angle with a protractor, in example 7, this is one that I have not shown you how to do yet. So for this example, I'd like you to take out a protractor so we can do it together. For example 7, we should have a protractor to help us here. I have this protractor here that has an arm, but I took the arm off to show you how to do it without one. In order to measure an angle, the lines have to go through your protractor. But we've got a problem. These lines are a little bit too short. So I will share with you what you should do. If your lines are too short, you can use the bottom of your protractor to extend the lines further so they can reach the edge. So I'm going to just take my ruler here on the side of my protractor, and I'm just going to extend the lines out, making them big. Now this should fit. To use a protractor, place the center of your protractor right where the dot is. Mine has this big gap, but again, when it has the arm in it, it's a very little dot that helps us. So I'm going to place my my protractor right here. It should now be rotated to line up with 0 degrees or 180 degrees along the bottom line. The small numbers that go this way counting up are for acute angles. The big numbers that get bigger going down are for obtuse angles. So in this case, we have an acute angle. If I look at my protractor, it seems like it goes through this line right here. And we know that this is an acute angle because it's less than 90 degrees. It's a little bit past 20, closer to 30 by just a hair. To count out, if 20 is this big line here, this is 21, 22, 23, 24, 25. This angle goes through 26. So we would call this a 26-degree angle and give it that marking. For an obtuse angle, just remember, you're looking at the bigger numbers. So if I want to measure this angle, doesn't reach. So I want to extend my lines. I'm also going to put the arm attachment back into my protractor to show you for this one how to use the arm attachment if you have one. There we go. That should be good enough. Just barely, but it works. Actually, I am going to extend it a little bit more in this particular direction, sort of through some of our other answers. If you have an arm attachment on your protractor, it's nice because you'll be able to see through it to see exactly what the angle measure is. So again, we line it up. If you have an arm attachment, you will just rotate your protractor until it's right through the middle of the line and take a look where the arrowhead is. According to this, if I move it and flip it over so I can take a look, the arrowhead is on that second one past 50, or past 130, I should say. So if I really take a look at it, this is the measure of the angle. That's 132 degrees. So I'm going to draw my angle and call this 132. Let's flip the page. The angle addition postulate. We already touched on this in some of our examples, but the angle addition postulate is a lot like the segment addition postulate. The angle addition postulate tells us that if if P is in the middle of the angle, then the measure of RST, the whole angle, is equal to the sum of the two smaller measures, RSP and PST. So these angles, we can add them together to make the big one. The measure of angle RST is the measure of angle RSP plus the measure of angle PST. So if in this example, the measure of angle DEF, that's the big one, is 168 degrees, and WEF, this left angle, is 90 degrees, well, I want to mark off my 90-degree angle. Again, we mark off right angles like a box corner. We have to find what angle DEW is. If the whole thing is 168, then 90 plus the measure of angle DEW has to equal 168, right? So what could DEW be? Well, you could subtract 90 from both sides and get that the measure of angle DEW equals 78 degrees. I'm going to skip number 2 for now, but it's a very similar notion. I want to move on to a problem like 3. So, the measure of angle RJK is not a specific number, it's an expression. 27x minus 2. The measure of angle IJK, the big one, is 180 degrees. This is a straight angle. All we know is that the measure of angle IJR, the small one here, is going to be, so let me give it a second marking, is going to be 4x minus 4. So somehow we have to find what x is. Good news though, we know that these two can add together to make 180. So we can just do 27x minus 2 plus 4x minus 4. Again, that's angle RJK plus the angle IJR, and that'll equal 180 degrees. All we need to do now is solve it. We can combine like terms to get 31x minus 6 equals 180 degrees. We can subtract 6 from both sides to get 31x equals 174, almost there now. All we have to do is figure out what x is by dividing 174 by 31. So if I do 174 divided by 31, I seem to get a little bit of a decimal. That's okay. Decimals are allowed in this class. We get x is approximately 5.61. Oh, I'm so sorry, everybody. I messed up. I wonder if you spotted the error before I did. I accidentally subtracted 6. If we want to solve this, we use our Algebra 1 skills to add 6. I'm so sorry, everyone. I misled you. 31x equals 186. I was wondering why the numbers wouldn't work out. We still can get decimals, but this one won't be one. This is x equals 6. Last but not least, I want to talk about what to do if we have bisected angles. So according to this diagram, the measure of angle IHG, the big angle, is 72 degrees. So this angle here, this big one, is 72 degrees. If HS bisects the angle, can we figure out what the measure of angle H, well, we got another error. This should be IHS, not HIS. The measure of angle IHS is? Well, if we have a bisection, keep in mind that bisect just means cut in half. So if the entire angle is 72 degrees, and it's being bisected, what's 72 cut in half? That's 36. So the measure of angle IHS equals 36 degrees. Bam. Thank you so much, everybody. That concludes our notes for today. I hope you have a fantastic rest of your day. Take care.